name is Sean Bergen, and I'm a member of the COMSYS Network Education team. In this video, I will discuss the importance of archiving your code. Most researchers give only a passing thought to archiving their software. They may have a copy stored on the cloud or on an old hard drive in case of a computer failure. But having a backup of your software is not the same as placing your software in an archive. Researchers may also use GitHub to develop their software and make their code available to others. But making your code available in GitHub is not equivalent to archiving it. Why do we need to archive our software? Put simply, research software must be properly archived in order to build upon it. Scientific reproducibility is a cornerstone of the scientific process. This means that software must be available in the future for researchers to reevaluate it, and it must be available for researchers to build upon it. For example, as part of a team of researchers, I helped develop an agent-based model of information flow and evacuation decision-making during hazardous weather events, such as hurricanes, called the CHIME model. My colleagues and I have published several articles about the model in order to disseminate the results. But in order for other researchers to evaluate the agent-based model we created, it must be archived in a location to allow others access in perpetuity to both the code and the data. Also, I don't just want other researchers to reproduce our results. We are hoping that the model will be useful for future research. We want other researchers to be able to find the code that we worked on, improve upon it, and build upon it in new ways. Archiving the CHIME agent-based model is essential so that researchers are able to do these things. In this module, I will discuss the importance of archiving your code, as well as the essential features you should look for in a software archive for your code. Much, if not most, of the scientific research that is being conducted or developed today contains scientific software. In order for that research to be reproducible and useful for other scientists, software must be preserved. This is especially true of computational models, which are increasing in complexity and number, but can often be rendered unusable with advances in computing and software. Software preservation, then, is an important component of the scientific process. In the early days of the internet, many people hosted scientific code on personal web pages. This approach provided access to a large number of people, but did not preserve that information for long. Now, most researchers recognize that personal web pages are ephemeral and inappropriate storage locations for scientific data and code. Now, there are many more permanent solutions for storing scientific software, but even official repositories do not last forever. The term link rot refers to the tendency for URLs to stop working as time progresses. A number of studies have estimated rates of drift, and it varies with time and content. This means the longer you have information on the internet, the greater the chance that a link will no longer work. And there are many reasons this can occur. Web servers shut down, they change names, they reorganize their file system, and their URLs change. Companies and even universities sometimes collapse. And unfortunately, computational software and datasets are often not as widely shared as the scientific articles that were published about them. With these issues in mind, researchers now turn to a number of organizations to aid in digital preservation. Unfortunately, no organization can guarantee that your software will be available forever. Digital preservation organizations like ours can run out of funds to host digital content indefinitely, or may be acquired by new organizations that do not share the same goals. However, if eternal preservation is the stated goal of an organization, then it is reasonable to trust that they will do what they can to preserve your digital information and tools. Some of the organizations that pledge to preserve your digital scientific code and data include COMSYS, Figshare, Zenodo, and the Open Science Foundation. There may be other organizations which are specific to your own area of research as well. Many software developers use, or at least have heard of, GitHub. GitHub is a platform for collaborative or individual software development that can help you track software changes and issues. It's not a digital archive, nor is it intended to be one. GitHub does have an archive program that has preserved a snapshot of all the repositories from February of 2020, and those snapshots are actually stored in a Norwegian coal mine. It also attempts to indefinitely archive popular projects, but there's no guarantee that your project will be one of them. In order to archive your repository in GitHub, a common approach is the use of Zenodo. Zenodo is an open access repository that can be used to make a snapshot of an archive in GitHub. And that snapshot is then given a permanent identifier. Our permanent identifier provides a persistent link to details about and access to the digital object. One such system is the use of digital object identifiers, or DOIs. A DOI is an identifier, not a location, of an entity on digital networks. It provides a system for persistent identification and interoperable exchange of managed information on digital networks. A DOI can be assigned to any entity, physical, digital, or abstract, primarily for sharing with any user community or managing an intellectual property. The DOI system is designed for interoperability, as you can use or work with other identifier and metadata schemes. DOI names may also be expressed as URLs. So how do you get a DOI? DOIs can only be issued by official agencies, and these agencies may issue DOIs based on their own criteria. For example, COMPSIS currently issues DOIs to agent-based models which have passed peer review, but does not issue a DOI to all uploaded software. Each agency is responsible for hosting the content that each DOI links to and making any necessary changes in the future. So if a file or folder moves, your DOI will always direct people to the proper location. In the next module, you will learn about the importance of providing documentation for your scientific code.